Okay, we're on to day 2, kids, and I got a fresh cup of coffee. Yes, whoever told me I should stop drinking coffee. I don't want to listen to you anymore. By the way, all of these can be found at www.nkinfinity.com. You can also go to, where is it? Is it on the bottom? Shouldn't it be on the bottom of all these pages? Algebra2, commoncore.com too. That'll just take you to NK Infinity anyway. So let's get started on day 2, compound probabilities. For the next little while, I'll try to keep my penmanship neat. My name is Mr. K. Let's see. Union. Let's see. A little warm up from yesterday. What do we remember about union? It's the probability that at least one of 2 or more events occurs. Big things I want you to remember is it's or. We're going to add the way you write it is the probability of A or B, that or symbol. Don't forget, we're adding. That is the union. The intersection is the probability that all of 2 or more events occurs. And what did I tell you I want you to remember about this? This is an and. An and means we're going to multiply. All right, today's not bad. You're going to be able to do all this stuff. Some of this is going to be a little bit of review. Some of it's not. And then it's going to get a little crazy. So I gave this one so you didn't want to have to rewrite it. I thought that'd be kind of silly. What is the probability of getting a heads and then a 3? Well, remember, counting principle, there are 12 outcomes. 2 on the first, 6 on the second, 12 outcomes. And there is only one getting a heads and a 3. Now, if I wanted to do this mathematically, because this is an and, it is the probability of heads and a 3, which is the probability of heads is a 1 out of 2, times the probability of getting a 3 is a 1 out of 6. If I multiply, I get 1/12. What is the probability of getting tails and an odd? So the probability of tails and odd. Okay, that would be the probability of tails is 1/2. The probability of odd is also 1/2, because remember, it's really, maybe I should write it like this. It's 3 out of 6, which then would be 3 out of 12 or 1/4. Do you have to rewind? Not really. What is the probability of getting heads and a prime number? Uh-oh. A new vocabulary word. Not a new vocabulary word, but a remembering vocabulary word. Prime number. Well, heads is easy. Prime is not, because everybody forgets. Now, prime, the definition of prime is a number that has exactly 2 factors. Exactly 2 factors. 1 is not prime. It only has 1 factor. It has 2 factors. So there are 3 numbers that are prime. 2, 3, and 5. On a die. There's lots of prime numbers, but those are the 3 that are prime on a die. So 3 out of 6 on this as well. So this is also a 3 out of 12 chance. Miss Postilli is playing a carnival game of chance. She must first roll a die. Oh. I didn't even finish. Oh, you know what? It's covering it. The rest of this word, I got to fix this. So I'll fix this before we print it. But the rest of the words should be saying, and then spin a spinner. What is the probability of rolling a 6 and spinning an even? Notice it's and. And. I don't need this here either. I got to fix all my mistakes. Again, first year teaching this, going to have some mistakes. Okay, probability of rolling a 6. So this is the probability of a 6 and even. So probability of 6, 1 out of 6. And the probability of even. Well, that's 2 out of 4, or 1/2 if I want to. So this would be 2 out of 24, or 1/12. And I got another mistake there. Probability of rolling a prime number and spinning a number greater than 1. All right, so this is the probability of prime and a number greater than 1. So the probability of prime we talked about is 3 out of 6 times a number greater than 1. That would be 2, 3, or 4. So that would be 3 out of 4, or a grand total of 9 out of 24. If you want, you can reduce them. You don't have to. Probability of rolling an even and spinning an even. So this is probability of even. So probability of even and even. Well, the probability of even on the first one is 1/2. We'll do 3 out of 6. Times the probability of even on the second, which is 2 out of 4. So this is 6 out of 24. Now someone might say, well, why don't you reduce? Why don't you reduce? Well, at the next question I asked you was, which had the most, or was the most likely to happen? And if you had them all in terms of 24, you could just say, oh, 2 out of 24, 9 out of 24, 6 out of 24. It looks like this is the most likely event of happening. Prime, and then a number greater than 1. If I reduced them, maybe you could, maybe you couldn't. All right, so that's a little bit of a warm-up. Now let's get going on some harder stuff. Depending on your background, you probably learned that or, probably should have put that one in there, or, how are we doing it? Means to add. We talked about this. The union, talked about this already. The union, I'm going to pick a different color. I don't like that color. Of two sets is the probability that at least one of two or more events occurs. The union of one of two or more events occurs. In the past, you've been told that in an OR situation, you will need to do is add up the events with various probabilities in order to determine the overall probability. This is only true if the events are what's called disjoint. New vocabulary word. Disjoint events are what's called mutually exclusive. Some new vocabulary, I believe, for you. All right, mutually exclusives. In other words, the probability, which means that the events cannot occur at the same times. In other words, the probability of A and there's a mistake in my thing. And B, the probability of A and B, which they cannot occur at the same time. So the probability that, you remember, in a AND event or an intersection event, the probability is you multiply them, but the probability of them both happening at the same time is 0. So let's take a look at this little diagram I have here. The probability that dart hits at least one of A or B is the area of A plus the area of B divided by the area of the rectangle. I don't know why I had you fill those in. I think we could have just talked about this. So if I want to know the probability that a dart hits A or B, it's all of this plus all of this divided by the area of this entire rectangle. And that's because the two events have no overlap. No overlap. We talked about overlap the other day. No overlap. The areas have no, it's not even English. Because the two areas have no overlap areas, they have no outcomes in common. Therefore, A and B are, why do I keep saying are disjoint. I think the copies I make for class are going to have less mistakes. Sorry about that. Are disjoint. Or in other words, they're mutually exclusive. They have no events in common. There's no overlapping. There's no event that's in A that's also in B. They have nothing in common. So here we go. The results of a die roll is odd. The results of a die roll is 4. These events have nothing in common. So, for example, let me give you an example. Event A, they're odd. That could be a 1, a 3, or a 5. Event B, the roll is a 4. Okay? Well, what are the other events that can't be in event A or event B? Well, that could be a 2 or a 6. Those are the ones that aren't in event A. So what is the probability of, so I want to know, what is the probability of event A or B? Well, they have no overlapping events, so it is just really the probability of A plus the probability of B. In other words, it is 3 out of 6 plus 1 out of 6, which is just 4 out of 6. And it's straightforward. There's no problem there. Selecting a card from a standard deck and getting an ace. B is selecting a card from a standard deck and getting a face card. Are the two events A and B disjoint? In other words, do they have nothing in common with each other? And the answer is yes, they are disjoint. Why? They have nothing in common. Nothing in common. And what is the probability of event A or B? Well, that's the probability, because of this, the probability of A plus the probability of B. Okay, which is really, let's see, ace is 4 out of 52. A face card, there's 12 of them. We talked about that the other day. 12 out of 52. That was in day 0. And that's 16 out of 52. Okay, let's try this one. Rolling a 10-sided die and getting a prime number is event A. Event B is rolling a 10-sided die, the same 10-sided die, and getting an even number greater than 5. Are the two events disjoint? Let's see. What are the prime numbers in a 10-sided die? The first one is 2. 2, is, by the way, is the only even prime number. 3, 5, 7. I think that's it. 8, 9, nope. 10, nope. 10's not. So that's it. What is the probability of rolling a number, an even number greater than 5? 6, 8, and 10. Do they have anything in common? No. So they are, in fact, disjoint. Again, nothing in common. Let's see. So this would be the probability then, because of they are disjoint, is probability of A plus the probability of B. In other words, let's see, the probability of A is 4 out of 10. I almost said 4 out of 52. I'm about to write 4 out of 52. 4 out of 10 plus 3 out of 10, which is 7 out of 10. In other words, what numbers aren't included? Well, the only numbers that aren't included is 1 because it's not prime. Let's see, what else is not included? 4 and what, 9? I think 9 is the only other one not included. So that again, notice this would be the complementary event of all of that stuff, of A or B. And notice they add up to 1. All right. I'll pause and I'm going to come back and we're going to talk about what happens when they have overlap. Oh yeah, coffee. All right, what if the situation does have some overlap? In other words, what if they have some things in common? For example, let's talk about if a die roll is odd or the result of a roll is greater than 3. Well, odd would be 1, 3, or 5. A result of a die is greater than 3, 5. Notice they have some things in common. So no, they are not disjoint. Have common elements. That's an E, by the way. Have common elements. So if I was listing this out and I said, okay, by the way, whenever you're listing out events and you have common elements, you need to put the common elements in the middle. 5 goes in the middle because it's in both event B and it's in event A. Now, event A has also a 1 and a 3 in it. Event B has, well, I should have, all numbers greater than 5. I should have said 4, 5, or greater than 3, 4, 5, or 6. Notice they have the 5 in common is what I should have said. So 4 and 6 belong here. So now we have a problem. Now we have the probability of A is equal to 3 out of 6. The probability of B, why did I write 4 divided by 6? I should just write the number 4 and then there's number 6. By the way, the only thing that's not used in this case is 2, so 2 should be out here. The probability of B is 3 out of 6. And if I were to simply add those up, I would get 6 out of 6. So is the probability that I get an odd number or a number greater than 3 1? Well, clearly not. And the reason it's clearly not is because I have this 2 out here. So it can't be equal to 1. So if I can't just simply add these up. So if I were to simply add these up, I would have a probability of 1. But that's not the case. But since 1 is, and let's just remind ourselves, 1 is the probability of a certain event. So what have we overestimated by? We've overestimated by having this one event out here, this one element out here that doesn't work. We've overestimated by that one element. Actually, what we've done is, not this element, what we've done is we've overestimated by this element because this element in the overlapping part has been added twice, and that's the thing we need to kind of get rid of. And by getting rid of, and we've talked about this again, we have to get rid of it by subtracting it out. So the general addition rule is the probability of A or B, and this is the one I want you to use all the time from now on. The probability of A plus the probability of B minus the probability of the joint event of A and B. Now this part in the middle here, this part in the middle here is the part where it's A and B. This is the A and B part. Maybe I should have done that in a different color. This part right here, I'll do it now, is the A and B part. That is the intersection of those two events. So in our simple example, the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Well, okay, the probability of A we said was 3 out of 6. The probability of B was 3 out of 6. And the probability of A and B of both occurring is 1 out of 6. So we add those up, we get 5 out of 6. Now this is a relatively simple example of this. It gets a lot more complicated. Don't think that's exactly where we're ending. So let's go through some examples. Well, I'm going to pause and I'll come right back for some examples. All right, so here's what we got. We've got the probability of A, the probability of B, and the probability of A and B. Simple example. I want to know what is the probability of A or B. Since they are not disjoint, and I know they are not disjoint because if they were disjoint, this would be equal to 0. So the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. In this case, it's 0.6 plus 0.3 minus 0.25, or 0.65. How about we do, you should be able to do this one last simple example. Again, these are not disjoint because this is not equal to 0. So I'm going to just do this. It's 0.65 plus 0.35. By the way, that's 1. So that would be the probability of a certain going to happen. It absolutely is going to happen. But minus probability that there's an intersection piece or the overlapping part, and we would get 0.9 for this. All right, so those are the simple examples. Now let me just work a little bit backwards here. So now I've got the probability of how I'm giving you the probability of an event, of the OR event happening. I'm giving you the probability of A, and I'm giving you the probability of their overlapping part, and I'm asking you for one of the pieces. So what you're going to want to do here is start with the formula. Start with that general addition rule. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of their overlapping part, which is A and B. Probability of A, 0.35. The probability of B, we don't know. It's the probability of B. Oh, we know the probability of A or B. We know that's 0.7. Minus the probability of A and B, we know that's 0.5. 0.15. All right, so this is 0.7 is equal to, now if I take this and put it together with this, I get 0.2 plus the probability of B. Subtract 0.2 and I find out the probability of B is a half, 0.5. See, you try one. You should pause this, by the way, and try this one on your own. But it's basically going to be the same general rule. So the probability of A, messy. Let me try to do this Gil Palermo style. Probability of A or B, the general addition rule, is equal to the probability of A plus the probability of B minus the overlapping part, minus the probability of A and B. So probability of A or B is 0.45. The probability of Oh, found another mistake. Sorry, children. This should say here the probability of A. So the probability of A or B is 0.55. The probability of A is 0.45. The probability of B we don't know in this case again. And the probability of A and B is 0.25. So 0.55 is equal to 0.2 plus probability of B. So in this case, the probability of B is simply equal to 0.35. Done. All right. Hilton High School population has 1,438 students. There are 703 students that are participating in sports programs. There are 381 that participate in various music programs. Overall, there are 905 students that participate in sports or music. What is the probability a student plays both sports and music? All right, so let's write this up. Let's get our formula down. Probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Now, we have to define our events. So let's say A is play sports. And B music, plays music, is in the music program. All right, so what do I have here? I have a total of 1,438 students. So the probability of A is 703 over 1,438. I got to add to that the probability of B, which is 381 over 1,438. There are 905 students that participate in either sports, there's the key word, or music. So that's this or, this 905, the or goes with this piece right here, the or piece. So I know that there are 905 of the 1,438 that play music. So what I don't know is how many play both. Both is and. See the and here? And the and goes with this piece. I don't know this. Okay, so I'm going to add these up. So I'll go over to my calculator. And I'll add up 703 plus 381, and I get 1084. So I know, coming over here now, I've got 904 over 1438 is equal to 1084 over 1438 minus the probability of A and B. So I'll just subtract this, subtract 1084 over 1438 minus 1084 over 1438. Sorry, I didn't give you a lot of room here, kids. So I'm going to subtract off, 904 minus, so I get negative 180. So I get negative 180 over 1438 is equal to the probability of A, excuse me, see how it's minus here, is equal to the negative probability of A and B. So what's the question asking for? What is the probability a student plays both sports and music? Well, the probability that they play both sports and music is 180 over 1438. There it is right there. Now, why did I get 179 on my notes here? Did I type in something wrong? Let me see if I typed something in wrong, because on my notes I have 179. So I should have 703 minus, plus 381, which is 1084. And then on the other side, I have 905. Oh, there it is. See how I did 904? It's 905. See, it's 905. 905 minus 1084. So that should be 179. So 179 is, in fact, correct. I apologize. I think you all saw me make that mistake and probably thought I wasn't going to catch it. This should be 179 over. And you know what? That really stinks, making that small mistake. You see, I made that. This is a point I want to make also. I made that small mistake right there in that problem. This probably would be, it could be a 4-point question, probably a 2-point question, but let's say it was a 4-point question. I would get 3 out of 4 points on a question I typed in a number in my calculator wrong. So that's why you really, really, really want to check your math. Go over these problems. Retype those things in your calculator. Just don't go look back at your calculator and go, oh yeah, I did that right. Oh, I did that right. Do them twice. That would be a dumb mistake to make. Right there. That kind of mistake would cost somebody from getting 100. Or passing. And you don't want that. Okay, today wasn't bad, right? Complementary events, overlapping events, and you learn the general addition rule. Hit subscribe, hit like. It's going to start getting crazy tomorrow, kids, all right? Make sure you're really staying with it. Catch you on the flip side. Goodbye.